All right, so to get started on learning about factoring, the first thing I want to talk about is the greatest common factor, the GCF. Congratulations, Jonathan. Okay, so when you have an expression, sometimes there's a common factor that you can factor out. So for the first expression here, now it's important to understand what the word factor means. Factor implies multiplication. If something is a factor, that means it's multiplied by something. So when you write something as factors, you need to write it as multiplication. The steps that I'm going to show here, you don't necessarily need to write them every time, but I just want to show you the way I'm thinking. So factors. So 3R, 3 is a factor, and R is a factor. 3 times R for that first term. Then we got a plus sign, and then 9 has factors 3 times 3. And what we can do is we can say, all right, it's basically it's the distributive property, but in reverse order. We're saying what factors show up in both terms so that we can pull that factor out. And it looks like we have a 3 that shows up as a factor in both terms. So we can factor that 3 out. And then we're basically dividing each term by 3, right? So it's going to take this 3 is going to divide out in a sense. And then this 3 is going to divide out. And then we're left with R plus 3 inside the parentheses. So it's basically just the backwards order of the distributive property, because the distributive property, you would normally take the R and multiply it through. And then, 3 times R would give you the 3R. And then 3 times 3 would give you the 9. So this is just factoring out the greatest common factor. When there's variables in both terms, then we can factor out variables as well, right? So we can think about this as so there's 4, and then there's 9 factors of n in the first term. And in the second term, there's 12 and then 1 factor of n. But 12 is 3 times 4, right? And n to the 9th, that's n times n to the 8th, right? If you if you're thinking about all the factors of n right there. So what we can do is we realize, all right, there's a factor of n in each term. So we can factor out an n. But there's also a factor of 4 in each term. So we can factor out the 4 as well. So if we factor the 4 and one of the n's out of the first term, the 4 comes out, one of the n's comes out, we're left with 8 factors of n. And then from the second term, if we factor out the n and the 4, all we're going to have left is the 3. And after you factor something out, you should always even if it's just a mental check, you should check and make sure, all right, if I distribute the 4n back through, do I get the original? 4n times n to the 8th. Yeah, that gives me 4n to the 9th. 4n times 3 would give me 12n. So that one's good. As a general rule, if the first term is negative, you want to factor out the negative as well. So if we look at this, we've got negative 12 and a as factors in the first one, and negative 3 is the only thing that's in our second term here. So if we can factor something out, the only thing we could factor out is a 3, because that's the only factor in that term. But since the first term is negative, we're going to factor out a negative 3. And this is something that you got to kind of watch out for. When you're factoring out the negative, you got to remember it changes the sign of every term. So if I take a negative 3 out of 12a, then I'm going to be left with 4a, because negative 3 times 4a would give me negative 12a. And then negative 3 times 1 would give me negative 3. So this is just 4a plus 1 left over after we factor out the negative 3. And then if we look at this one here, 12 and 16. So what are the factors of 12? 12 is 3 times 4. 16 is 4 times 4. So we've got a factor of 4 in each term. I know I can factor out a 4. And then the first term has 5 factors of n, and the second term has 3 factors of n. So we can factor out 3 of those n's. So I need to erase my parentheses up there, too close. So we can factor out also 3 factors of n from each term. So then what's going to be left inside? 12 divided by 4 is 3. And then if you have 5 factors of n and you take out 3 of them, you've got 2 factors left. And then just check to make sure if I multiply these together, do I get 12n to the 5th? And yeah, you do. And then for the last term, 4 times 4 gives you 16. And we took out all 3 factors of n. So it's just a 4 at the end there. So we factor out 4n to the 3rd. And then we're left with 3n squared plus 4. So this isn't necessary. This is part of simplifying at times, but these values didn't change, right? We just wrote it here. It's written as addition of 2 terms, and now after we factored it, it's written as a multiplication of 2 factors. Okay, so then if there's 3 terms, then you have to look and see what comes out of all 3 terms. So what factors do all 3 of these terms have in common? Well, it looks like 5 goes into all of them, right? So the only thing I can factor out of here is a 5. So I'll be left with k squared minus 40 divided by 5 is 8. So 8k plus 10 divided by 5 is 2. So even if there's 3 terms, you can still pull out a greatest common factor, but it has to be a factor in all the terms, because you have to be able to distribute that 5 back through and get the original expression. 63m to the 6th. So when I look at this, I'm looking at the 63 and the 49 and the 21, and it looks like 7 goes into all of those. And then look at the variables. If you have a variable in all 3 terms, so we have an m show up in all 3 terms, that means we can factor out an m also. So I'm going to factor out a 7m and then see what we're left with. So 63 divided by 7 is that 9? 7 times 9, 63. And then if we take one of the m's out, we'll have m to the 5th left. 7 times 7 is 49. So this is going to be 7m to the 4th, because we're taking out one m and the 7. And then 7 times 3 is 21. And we're taking that m out, so we don't have any left in there. So these last 2, it looks like on this first one, 9 times 9 is 81. 9 times 4 is 36, and 9 times 2 is 18. So it looks like we can factor a 9 out. So 9 times 9 gives us 81. So it'll be 9r squared minus 4r minus, each time we're just taking out the 9 here, minus 2. And then again, if your leading term is negative, you want to factor out the negatives with it. So what goes into 36 and 12 and 28? Let's see, 28 is, that's 7 times 4, right? 12 is 3 times 4, and 36 is 9 times 4. So and there's not an n in the last term. So the most that we can take out is 4. But since the leading term is negative, we're going to factor out -4. Okay, so we're taking out the 4 and the negative. So then what we're going to have here is 9n to the third. And then remember, so here we're taking out the 4 and the negative. So we're going to have plus 3n. And then from the last term, we're taking out the 4 and the negative. So we're just going to have plus 7. And then on big crazy ones like that, we often want to like double check and make sure that if we were to multiply it out, it would work. So you just want to run through and double check. -4 times 9 will give you -36. -4 times 3 would give you -12. And -4 times 7 would give you -28. Okay, so that is a quick review of factoring out a greatest common factor.